This is our last chapter. And majority of things of this chapter we have learned. That does not mean we will not revise, we'll revise everything. But our learning should be more reinforced on this chapter now. Okay. Again, this chapter में भी बहुत कटपिट किया है CBSE ने. And why they have done a lot of editing, because a lot portion of this chapter, which I feel is the very interesting part of the chapter, has been taken now to grade 11. Earlier we used to study in 9th. आजा, अर्लियर हम 9th में भी पढ़ते थे, आराम से 9th में भी पढ़ते थे, 11 में भी पढ़ते थे. अभी 9th वाला पार्ट को पूरा ही CBSE ने निकाल दिया है. ओके, सो यू स्टडी दिस एवरीथिंग इन 11, बट एट टाइम परमिट्स आई विल कीप ऑन टेलिंग यू दोस स्टोरीज ताकि आपको इंटरेस्टिंग लगना शुरू करे. एंड मेजर पार्ट ऑफ द चैप्टर वी कवर्ड, सो दिस विल बी ओवरलैपिंग टॉपिक. ओके, थोड़ा सा ओवरलैप करेगा, बट लेट अस. And this chapter is more about a storytelling chapter. इसमें कोई mathematics नहीं है, कुछ भी नहीं है. It's a story. कहानी की तरह सुनते जाइए. Structure of atom. ठीक है? Structure of atom. Name itself is against John Dalton's atomic model. You are trying to study the structure of atom. That means atom is, how is the structure of atom? What is inside an atom? What is outside an atom? What comprises an atom? What constitutes an atom? So Dalton is not very happy with these thoughts, because as per Dalton, the rule is that atom is indivisible. Atom cannot be divided. Okay. So this part of chemistry, which you are studying as structure of atom, let me give you some idea. In grade 11, this will be your startup, your second chapter, basically your second chapter. Moles have been taken away from you. So moles form the first chapter of grade 11 now, called Some Basic Concepts of Chemistry. The chapter's name is very easy, and many children flunk in that chapter because those concepts are not taught in grade 9. Okay, so if time permits, we'll do some mole problems also later on. Structure of atoms. From here, you are not chemistries. What type of chemistry? What are the types of chemistry? You know, inorganic, organic, physical. This is modern chemistry, atomic chemistry. And in CBSE, in grade 11, whatever you study in chemistry, do not waste your notes, because in grade 12, same chapter and same things are there. There the name is modern physics, atomic physics. तो ये कहानी आप 3 बार पढ़ते थे हम लोग पहले, 9, 11, 12. Now you will study in 11 as well as in 12. So some concepts you will study here. You will be studying at a very, very higher level now, because there's a lot of editing CBSE has done. Okay. Now, structure of atom. Before we start this chapter, by this time you have to understand that the atom is divisible. और ये कहानी वाला चैप्टर है, बस सुनते रहना है इसको. The atom is divisible, and we are in the period somewhere around 1880s to 1898. इस period में हम चल रहे हैं. Is this time a lot of advancement in science had happened, so much which has not even happened today. Okay, some of the reason is in geography and all, you must have read, in history, like the Industrial Revolution, Renaissance, and all these things bringing up enlightenment of science came out. Okay, so many things were discovered, many phenomena were discovered, and after that, this period also saw some of the revolutions coming up. The Russian Revolution, not Russian Revolution is after this, the French Revolution, and going forward, you will see the period of the wars, the World War. It started from, like, one of the war is from 1919, okay, 1914, 1919, then you will see another war from 1939 to 1945. इस बीच में जितने चीज बने, इतना दुनिया ने कभी नहीं देखा था. You name anything, radioactivity, World War period, camera, World War period, bioscope, that's projector, World War period, motorcycle, World War, machine gun, World War, anything, television, जो आप सोच सकते हो, radio, सब कुछ World War period में होना शुरू हो गया. So much so that if we go back to some date lines, you know, so you see the progress in the year around, say, 1886, it's attributed to the discovery of proton. 1897 is attributed to the discovery of what you call electron. Around some 1908 or 1914ish, I'm not so clear. Okay, 1912, April 12, 1912, Titanic sank. Okay, so around 1914 ke aspas, the nucleus is being conceptualized. In 1932, the neutron has been discovered, and by 1945, Hiroshima has been bombed. So see the advancement of science. Huge advancement. तो ये period जब आप पढ़ने आ रहे हो ना, so you have to go back in that period and understand it like a story. Let us observe it. Okay. तो चलिए आइए इसको कहानी की तरह सुनने की कोशिश करते हैं. So we start with the atom and we go back to the period. All books will start first with something called discovery of electron. Discovery of electron. Discovery of electron is attributed to the scientist named J.J. Thomson. And approximately 1897 is the year they take, just taken as discovery. J.J. Thomson को Nobel Prize में मिल चुका है इसके लिए, ठीक है. J.J. Thomson is the person who is attributed with the discovery of discovery of electron. Your book now does not tell anything about how the discovery of electron took place. So the discovery of electron, if you want to know as a study, like you'll study all these in grade 11 now. These electrons, when they were discovered, they were known as something called cathode rays. Cathode rays, okay, like the television which you have, CRT, the old days television which we had, box type, colored television. CRT bolte the na, CRT is a cathode ray tube. So electrons are bombarded on the screen. So J.J. Thomson took some gas at a very low pressure, and he introduced high voltage electricity between two plates, and he took gases at a very low pressure, and he found. तो थोड़ा सा आपको कहानी बता देते हैं, हालांकि आपकी 9th में नहीं है. How the discovery happened. So an evacuated tube was taken. Okay, it's a tube like this. This is an evacuated tube, and we reduced entire pressure of this tube. सुनते जाओ, इसको लिखने बनाने की नहीं, आपके चैप्टर में नहीं है ये. Enjoy the story. This is not in your syllabus. Your syllabus says discovery of electrons happened. My heart doesn't tell you that इतना मैं छोड़ दूं आपको. आप थोड़ा सुनो ये कैसे था. So a tube was taken. This tube was made, they took out all the pressure from the tube. इसको vacuum कर दिया, and two plates were taken. Okay, and one of the plate obviously was connected to the negative side. Okay, and one of the plate was connected to the positive side. He took gases at a very low pressure. Gas at low pressure, almost vacuum कर दिया. And then when high current was passed, he found that there is a glow behind the anode. Cathode जानते हैं ना, CN. So there are rays which travel from this side, and these rays cause a glow behind the anode. Those days these were known as cathode rays. Okay, cathode rays. अब इनको इसके ऊपर स्टडी करना शुरू किया. कैसे स्टडी करना शुरू किया? जैसे ये रेज जा रहे थे, the first thing he did is that some object was kept in between, say some object was kept, shadow was created. That means these rays travel in a straight line. Okay. Next, what they did, they brought some electrical field in its vicinity, plus or minus field leke aaya. All the rays got bent towards the plus. That means these rays are negatively charged. Magnetic field aaya, then also the rays got deviated. So that also proves that the rays are charged. Charged rays are like current, and current will always undergo distortion in a magnetic field. What was more interesting is that they placed some very light pedal wheels out here, light pedal wheels. And as the rays travel, they could rotate these pedal wheels. Very light. That means what? The rays have mass in them. Are you understanding? They have mass in them. Momentum hai unke andar. They carry kinetic energy with them. That's why they are able to do work on this pedal. So what were these rays? These are cathode rays. So then they termed these rays as what? Since the rays are originating from the cathode, the rays were termed as cathode rays. Cathode rays which are negatively charged, which get deflected by negative field, which have mass in them. तो बहुत लोग इन्हें cathode rays की जगह इन्हें particles बोलना शुरू कर दिया. I just can't call it rays now. They've got mass in them. Right. Then he changed the gas. Then he started to find something which you learn in 11 called the E/m ratio, electron over its mass ratio. Now, whenever he is changing the gas, this E/m ratio is unaltered. That means what you are discovering is something which is fundamental. ये this does not depend on any type of material. आप गैस बदलते जाइए, you are getting the same cathode rays. Blood is fundamental in your body and my body. Even if I don't show your face and puncture your finger, blood will come out. Even if I don't show her face and puncture her finger, blood will come out. So what do we say? Blood is fundamental. Fundamental. So these rays which you are trying to get, or which J.J. Thomson got and he discovered, these rays are fundamental property of matter. And they are not at an atomic level, they are at a subatomic level. इन्हीं rays को आगे जाके J.J. Thomson gave them a name. And the name he gave was that these are electrons. He gave the name as electrons. J.J. Thomson बहुत चालाक आदमी था actually. Those days internet and all these things were not there, so lot of advancement was happening in America, and a lot of study happened in Germany, plus a lot of study also used to happen in Russia. Then if you see the socio-political world, एक तरफ में धीरे धीरे capitalist mentality आना शुरू हुआ. America after the war wanted everything to be, you know, the splitting of Germany. Okay, they brought West Germany, which is like the capitalist, and East Germany was the communist Germany, okay, which went to was under the Russian regime. वो Russian regime गया, तो इनके बीच में भी ये खिंचापिची उस टाइम पे भी चलते रहता था, ऐसा नहीं किया. Germany used to progress like anything. J.J. Thomson ऐसे ही कोई नहीं कि उसने ये बनाना शुरू कर दिया, कैथोड रेज बनाना शुरू कर दिया. This is a very nice interesting story. Discovery of electron is given to the year of 1897. So at grade 9, your book tells only one thing, that the electrons were discovered by J.J. Thomson, and it was discovered in the year 1897. Now, the thought comes, if there is a ray which is coming from cathode, should there not be a ray which comes out from the anode also? And the idea of anode rays then struck with J.J. Thomson. But यहाँ कहानी में एक twist आ जाता है. J.J. Thomson tried his level best to also have the accreditation for protons in his name, but it is not given to him. Protons की discovery अगर आप देखो, if you see in any book, every book will start with this and then say protons were discovered back in 1886 itself. But nobody knew it was proton. There was a German guy and his name was Eugen, we call it as Eugen Goldstein. Eugen Goldstein was nowhere interested in all these cathode ray and all. He was doing work on television purpose. He also had a ray tube, and he had documented about anode rays at that time, just that he did not give the name as anode, he just gave it anode rays and all. Ye bhai sahab, after finding cathode rays, got an interest that there should be something called anode rays also. Right? But anode rays ki kahani or interesting hai. Anode rays are said to be proton. Well, not exactly. Same sort of phenomenon was done. Same setup was done for this case also. This time, the rays are traveling from this side. Okay, the rays are traveling. So, आप बोल सकते हो, sir, how can it be that sometimes you get cathode and sometimes you get anode? You actually get cathode and anode on the same tube. In the case of cathode rays, if you change the gas, ratio does not change. But in the case of anode rays, if you change the gas, the ratio changes. So in higher grade, they tell you, are anode rays proton? Anode rays means they are coming from anode, and they have the same property. They travel in a straight line. They are deflected by electrical and magnetic field. They possess mass in them. They can also rotate pedals. But the interesting part is that the moment you change the gas, the ratio changes. So what they did, they started testing it with hydrogen. Okay, actually anode ray होता क्या है देखो, ये आपका negative side है और ये आपका positive side है. Okay, now whenever you are putting high voltage out here, all the electrons of that particular atom, यहाँ पे जो atom है ना, the atom's electron is getting sucked on this side. So what are you left with? If it is hydrogen, hydrogen has only one electron and one proton. Children, these are not in grade 9 syllabus. I'm saying it for your interest. There's a hydrogen atom. It has one electron, one proton. The electron is pulled by the positive plate. So what you have now is a proton. Proton gets pulled by the negative side. So in higher classes, they always ask you, Are anode rays protons? We say anode rays are protons only under one criteria, if the gas inside is hydrogen. Otherwise, they are not protons. Because hydrogen is one atom which carries only an electron and a proton. So सवाल आता है, sir, if you don't take hydrogen and you take a different gas inside, then what is that ray called? I would say those rays are ionized gas rays. It can be any gas. Ionized. Ionized means their electrons have been knocked off. Now they are like ions. They're a stream of ions. But if it is hydrogen, then the stream of ion is what? Proton. Right. So if we go back, these whole stories you will study in grade 11. So if we go back to grade 9, we first say that the year 1897 saw something which is known as the discovery of electron. आपके लिए ये important है. Discovery of electron. And what is electron? An electron is a negatively charged particle which is present in the atom. हम लोग अभी 1897 में है. आप न्यूक्लियस मत बोलिए अभी. न्यूक्लियस अभी जन्म ही नहीं लिया है. Where are we? We are in 1897. So in 1897 we just found that the discovery of electron, and some previous papers were also there in 1886 roughly, and that was the discovery of proton. Proton is a positively charged particle. Okay, proton is a positively charged particle, electron is a negatively charged particle. So by 1900, the concept of atom that you have with you is that an atom contains positive particles as well as negative particles. Positives are known as protons, negatives are known as electrons. ठीक है? इसकी discovery is credited to J.J. Thomson. इतना आप लिख लीजिए. This is for your interest. This is for J.J. Thomson, and this is accredited to Eugen Goldstein. Eugen Goldstein. Eugen Goldstein. This much you write down. We are at 1900 now. At 1900, the atom is thought to comprise of only protons and electrons. Protons are positively charged particles. Electrons are negatively charged particles. Protons ki discovery is credited to German scientist Eugen Goldstein. But Goldstein never was interested in protons and all. He discovered some rays which he had documented and kept. Many years later, when electrons were discovered as a fallout of cathode rays, electrons are also known as, electrons came out as the result of cathode rays. Goldstein was working on anode rays, but Goldstein did not name them as proton or anything. When cathode rays came out, then people said, is there something called anode ray? Then they found, yeah, in some study, some anode rays ke baare mein was also documented. And for a little bit higher study, are anode rays protons? Anode rays are protons. Protons, IFF. IFF means if and only if the gas is hydrogen. Otherwise, anode rays are not protons. बहुत सारे बुक में लिखेंगे anode rays were protons. No, anode rays are protons only if the gas inside the gas discharge tube, that gas discharge tube is hydrogen. हालांकि इलेक्ट्रॉन के केस में उस डिस्चार्ज ट्यूब में कोई भी गैस डालो वो इलेक्ट्रॉन ही है. All cathode rays are electrons, but all anode rays are not protons. Anode rays which are emitted when the gas inside the tube is hydrogen is only. This is for your higher level understanding. But at this level, इतना हमको जानना चाहिए. ठीक है? इतना तो आप लिख लीजिए. There is one experiment which you have to understand in detail. Okay. चलते हैं आगे चले. Right. Grade 9 study starts from something called discovery of nucleus. ठीक है, इससे पहले where are we are in 1900 के आसपास. So far we know we have got an atom, and inside the atom we have got electrons, which are negatively charged particles. Okay, we have got electrons, which are negatively charged particles, and we have protons, which are positively charged particles, right? So at this level some structure of atom was postulated. Postulated matlab samajh rahe hain, somebody proposed. So the first structure of atom which was given at this time was given by J.J. Thomson, and this model is known as the plum and pudding model. The plum and the pudding model. So we have to first understand what is plum and pudding model of an atom, right? So according to J.J. Thomson, atom was a spherical structure. Atom was a spherical structure where the number of protons always equal to the number of protons. That means atom as a whole was electrically neutral. Atom kaisa tha beta? Electrically neutral tha. So the number of electrons always equals to the number of protons. This resulted in him stating that the atom was electrically neutral. Matlab isme koi charge nahi hai. Then people asked, what should be the structure of the atom? So he said that the atom structure is like a plum and a pudding model. अंग्रेज था, plum and pudding बोला, तो हम इसको थोड़ा देसी सिस्टम में समझते हैं. His plum and pudding is same like our kheer and badam model. Have you seen kheer? It is given to you in one big katora, and badams are just spread over it. Yes or no? Okay. So he said that in this whole atom, the atom was a negative sphere. नहीं, positive sphere. मैं खुद ही confuse हो गया. That's 1 minute. I'm so sorry. Just 1 minute. Just 1 minute. Yeah, the atom was a, very sorry children, the whole atom is a positive sphere. Positive sphere, and that means the atom is like this: positive, 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 positive. Jitne positives hone chahiye. It's, and this positive sphere where the positive charges are uniformly spread. This is analogous to the pudding, or in our desi bhasha, if J.J. Thomson was Indian, he would have said kheer ki tarah hai. Pura positive charge kheer ki tarah बिखरा हुआ है. Are you understanding? Pudding की तरह बिखरा हुआ है. And the negative electrons occupy spaces as if they are pieces of plum. ये हमारे negative electrons, and these negative electrons are like the pieces of plums. That's why it is known as the plum and pudding model. Pudding में plum के टुकड़े रहते हैं ना, छोटे छोटे. उसी तरह ये पूरा atom एक pudding है, positive pudding. इसमें negative plums. It was also known as the watermelon model. Have you seen a watermelon? When you slice it, the entire watermelon is pink in color. So the watermelon's pink portion is the uniformly spread positive, and the black seeds are just distributed over it. ये चीज watermelon model की तरह भी है. अब एक watermelon बना के दिखाते हैं आपको. अगर हम एक watermelon को slice करें तो हमें कैसा दिखेगा? Our watermelon will look like this. Don't you think? Right? And imagine that I can't draw black. Yeah, it's taking black color, and the black seeds are spread on it. Right? So these are my electrons, and the pink uniform spread is my proton. Tell me, children, have you understood what is plum and pudding model? So the plum and pudding model was proposed by J.J. Thomson. कुछ दिनों तक चला. यहाँ अभी आप देखोगे कि स्टोरी बड़ा इंटरेस्टिंग है. Whoever gives some theory will give a model. People will award him for them, and then one Dipanshu will come and he will give a new theory, which will actually make this theory whole look like stupid. Again, he gets a Nobel Prize. Again, his theory will be made stupid by someone else, and this goes on, goes on, goes on. And in today's present world, Schrödinger के बाद और कोई नया थ्योरी नहीं आया जो इसके पहले बाकी सबके. सबसे पहले जे थॉमसन अपना थ्योरी देता है. जे थॉमसन्स थ्योरी विल बी just thrown apart by Rutherford. Rutherford's theory will be thrown apart by Niels Bohr. Niels Bohr's postulates will be thrown apart by Schrödinger. और वो मॉडल अभी चलता है. It's a very evolving thing. Till today also there are some studies done on it. ये जो quantum mechanical model होता है, ठीक है. So we are at a very primitive stage. We are at 1900, and at 1900 electron and proton was known to us. And J.J. Thomson was the first person to propose a model of the atom, and the model he gave came to be known very famous as the plum and the pudding model, in which the atom is conceptualized to be a sphere with the positive charge uniformly spread across it like a pudding. लेप की तरह है, खीर की तरह है, और उसमें बादाम की तरह प्लम के पीसेस बिखरे हुए हैं. And what are these? These are the positive charged protons, and the count should be same. Got it? It's also similar like the watermelon model. When you slice a watermelon, then you see entire inside like pink. So the pink portion is the positive spread, and on that the seeds are black in color, which are distributed and randomly distributed, and those seeds are known as. Remember this model very nicely, हाँ? ये model हमें काम में आएगा अभी. So this was the model given by J.J. Thomson. लेकिन दुनिया ऐसा नहीं था. उसके बाद कहानी में आता है एक नया ट्विस्ट. कहानी में आता है एक नया ट्विस्ट, एंड आई एम कीपिंग दिस स्मॉल क्योंकि ये मॉडल आपको काम में आएगा. ये रहने दो यहाँ पे, ठीक है. देन कम्स अ पर्सन whose name was Ernst Rutherford. Yeah, Ernst Rutherford. Ernst Rutherford was a Kiwi. He belonged to New Zealand. Okay, and he also has a Nobel Prize to his name, and his Nobel Prize is accredited to the discovery of nucleus in the year 1911. But Rutherford dies very young. 40 साल की उम्र में उनकी मृत्यु हो जाती है, ठीक है. He dies very young. Now we all study that Rutherford was the man who discovered nucleus and all. This is what you'll get in books. और interesting कहानी सुनो. Rutherford उस जमाने के बहुत बड़े रईसजादे थे. He was a very high class person who owned a radioactive company in those days. Somewhat like Ambani type था, मतलब उस जमाने में उनका पेट्रोलियम का कंपनी था. तो जाहिर सी बात है, he must have had lot of engineers and scientists in those days. So there were two scientists in his. This your books will not tell now. Higher पढ़ेंगे तो समझें. इनके यहाँ दो साइंटिस्ट थे, गीगर एंड एक और था मार्सडेन. These are the two rabbits who actually worked for this whole experiment. Credit is actually in the name of Rutherford. क्योंकि पेटेंट इन लोगों ने अप्लाई किया. Patent was applied in the name of the company, Rutherford की radioactive company के नाम पे, and Rutherford. In fact, Geiger Marsden के बहुत सारे findings है radioactivity में. So Geiger Marsden started doing one experiment, which I am saying as Geiger Marsden. आप मत देखिएगा, आपके लिए वो क्या रहेगा? Rutherford's experiment ही रहेगा. दुनिया ऐसे. Who built the ताजमहल? शाहजहां built ताजमहल. शाहजहां ने एक ईटा भी उठाया था क्या कभी? मजदूरों ने ही तो उठाया होगा ना. मजदूर के नाम तो आप नहीं जानते हैं. But in this company there were two young scientists whose name were Geiger and Marsden. So they were actually doing an experiment, and that experiment is profoundly known as and very famous known as Rutherford's, और Rutherford ने उस पे अपना नाम चिपकाया. Rutherford's gold leaf experiment. Rutherford's gold leaf experiment, and let's see this experiment in detail now. Okay, what Rutherford did, he took a thin foil of gold, something like what you have inside in your Cadbury's Dairy Milk के wrapper में जैसे आता है ना, thin roll. Gold ही क्यों लिया? Gold इसलिए लिया because gold's atomic number is quite high, number of protons are also high. Okay, so he took a thin foil of gold, and The experiment is somewhat like this. I have to show it to you. Okay. A thin foil of gold, and he bombarded gold with some particles which are known as alpha particles. So before we start this experiment, we should also like to know what is an alpha particle. So isse pehle, so children, when you have a radioactive substance, now you don't have radioactivity in your syllabus, but dekh lete hain. Radioactivity. What is radioactivity? There are certain substances which undergo spontaneous emission of invisible radiation. कुछ करने की जरूरत नहीं है आपको, ये हमेशा एक रेडिएशन छोड़ता जाएगा, which are harmful. So the radiations that they leave are three type of radiations. The first radiation is known as alpha particles. Rays बहुत लोग बोलते हैं, rays is not the right word because they'll have mass. Alpha particles, beta particles, okay, and they also release something called gamma rays. These are known as gamma rays. Our interest is on this thing, alpha particle. Okay. Any radioactive substance. What is radioactivity? Radioactivity is the process in which there is spontaneous emission of invisible radiation. छोड़ते ही जाएगा वो radiation, छोड़, आपको कुछ करने की जरूरत ही नहीं है, बस छोड़ते जाएगा, and radioactive decay होता जाता है. These are not chemical reactions that you are studying now. All the chemical reactions that you studied, in those electrons took part. Atoms never changed. Carbon reacts with oxygen to form carbon dioxide. The carbon atom remains the carbon atom in the molecule. Rearrangement of electron happens. Why this field of chemistry studied separately? These are nuclear reaction. पूरा nucleus ही बदल जाएगा. Element will transform. Please understand. An element, for example, a carbon will undergo beta decay and will become something like nitrogen. अरे element ही change हो जाएगा जब आप higher classes में पढ़ोगे. तो हमें alpha particle जानना. We need to understand what is alpha particle. So let's say let's understand what is alpha particles. Then we will be able to understand the experiment properly. Let's look at an inert gas called helium. What is the atomic number of helium? 2. What is the mass number of helium? 4. So let us look at helium as a structure. This is the helium nucleus. In helium nucleus, I have got how many? 2 protons and 2 neutrons. Do you agree? And it's a single shell where I have 2 electrons. Right? समझ में आया? This is helium. Helium का atomic number is 2 and mass number is 4. So if we go by count, helium has 2 electrons, 2 protons, and 2 neutrons. These two make your mass number of 4. Is this clear? If you can, what are alpha particles? Alpha particles are same as the helium nucleus, but they do not have these 2 electrons. तो अल्फा पार्टिकल को हम कैसे दिखाते हैं? He2+. He2+, and another way of writing it is we write it like this. He ये 2+ है और 4. 4 means an alpha particle is a helium nucleus whose 2 electrons have been taken away. Your question is, does helium become alpha particle? No, 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 no. It is a way to understand. What is a gulab jamun? A gulab jamun is a rasgulla whose outer shield has got a reddish brown color. That means gulab jamun and rasgulla are not same. Because you don't understand what is gulab jamun and you have seen rasgulla before, that is the easiest way I can explain you what is the gulab jamun. And taste mitha mitha like a rasgulla. So what is an alpha particle? An alpha particle को हम बोलते हैं, इसको हम बोलते हैं, alpha particle is known as a doubly charged helium nucleus. Now look at this word, very interesting. Doubly charged means 2+ because 2 electrons were lost. Helium nucleus, because once you lose the 2 electrons, then ये orbit तो हमारा रहेगा ही नहीं ना. दोनों इलेक्ट्रॉन चले गए तो ऑर्बिट चला गया. आपके पास क्या बचा? सिर्फ हीलियम का न्यूक्लियस बचा. Helium does not undergo this thing. Helium is the rasgulla. ठीक है? So whenever we talk about 2He, He2 plus 4, this is actually my alpha particle. Yes.
Then it will not exist, right? Because it will not balance.
Don't look it from helium's perspective. That's why this particular item undergoes radiation. This is a radiation that you are getting. This radiation is in the form of a particle. Alpha particle is a positive particle. Beta particle is a negative particle. And gamma rays are neutral particle, not particles. Gamma rays do not have any mass. They just have energy with them. How is this particle? Can you, sir, say how this particle looks like? This particle is just like if you have a helium nucleus and you don't have the electrons, then the helium carries 2 positive charge and has a mass number of 4. That is alpha particle. आप हीलियम की स्टेबिलिटी के बारे में मत देखो. हीलियम is given shown to you just for comparison. Your question was like, then to sir, it is not a rasgulla if you have colored it. I have never colored a rasgulla. I bought a sweet which is gulab jamun and you have never eaten it. The nearest thing that you have eaten to a gulab jamun is a rasgulla. This is a rasgulla. So I'm trying to explain you how a gulab jamun looks like in terms of a rasgulla. You came to a British guy and you ate Italian guy and you ate pizza. लाइफ में पहली बार खाए हो. घर जाके घर वालों को कैसे समझाओगे? कुछ पराठा जैसा ही था, पर उसके ऊपर बहुत कुछ बिखरा हुआ था. So what is a pizza? A pizza is a paratha with lot of garnishings. और पता नहीं मलाई मलाई टाइट मलाई जैसा चीज था. चीज भी नहीं खाए हो पहले, मलाई बहुत खाए हो, है ना? घी जैसा स्मेल था पर घी नहीं था. ऐसे ही तो समझाओगे. The paratha is taken a base. That does not mean that sir paratha pizza बन गया. हीलियम ही है. आपको समझाने के लिए the alpha particle is a particle which is similar as if you take a helium atom, knock its 2 electrons, so it gets double positive charge, but retains its mass number of 4. That's why an alpha particle is known as doubly charged helium nucleus. At grade 9 level, the thing that you should know, my alpha particle is somewhat like a positively charged particle. ये याद रखो, ये positive charged particle है. Understood? Right, fine. So let's go ahead and see how this experiment looks like. So what Rutherford did, they had something which is known as a, अभी ड्राइंग मत करो पहले से, ठीक है? पहले समझो, आपको कुछ पता ही नहीं है इसके बारे में. So they enclosed a radioactive substance inside a lead box. Sir, why do you take lead box? Lead is supposed to absorb all radioactivity, ताकि बाहर कोई चीज लीक ना करे. ठीक है? Radioactivity तो dangerous होता है. So this is a lead box enclosure, and inside this lead box, what did they do? They left a radioactive sample. It is a radioactive, some radioactive sample. Now this radioactive sample is going to release rays, and we are interested in alpha rays or alpha particles. Okay, so once the alpha particle comes out, the others can be absorbed. So many people will say, sir, how can you absorb the others? दूसरा electric pole दे दो तो betas are negatively charged, तो beta को absorb करके ले लेगा. So you have alpha particle, and this fellow took that, वो जो gold था ना, thin foil of gold he had taken. The thin foil of gold was something like this. A thin foil of gold. I'll just retain this for 1 or 2 minutes only. Okay, this foil of gold. Then I'll change, what do you call, the this चीज को हटा दूंगा उसके बाद. And thin foil of gold was taken, and after that, our friend, what he did, he created a screen behind. ऐसा एक screen रखा, and this screen is coated with something which is known as zinc sulfide. So this is this is the lead box, lead एनक्लोजर, और लेड एनक्लोजर के अंदर क्या है, रेडियो एक्टिव सैंपल है, रेडियो एक्टिव सैंपल। बढ़िया लग जाएगा आपको ये पढ़ के, देखो हाउ ही विल destroy Thomson's model. Radioactive sample, and this is thin foil, very very thin foil, and this thin foil is of gold, and he kept a screen on the other side. ये screen है, and the screen is coated with zinc sulfide. Why did he coat it with zinc sulfide? Zinc sulfide creates fluorescence when a alpha particle comes and strikes it. अब अगर अल्फा पार्टिकल आके यहाँ पे स्ट्राइक करेगा ना, वो जगह इल्यूमिनेट हो जाएगा, ठीक है। So zinc sulfide was taken. Now, what our friend did? Our friend started bombarding this with alpha particle. So this is called bombarding with alpha particle. So alpha particles got emitted and started bombarding them. ये हमारे alpha particles. All these alpha particles went, and they went and went and went and hit what you call the gold foil. This is the experiment, Giger-Marsden setup. So what is the experiment setup? A thin foil of gold was taken and it was bombarded with a stream of alpha particles. What are these, children? These are alpha particles. These are alpha particles. Alpha particles matlab positive particles. These have come and bombarded. After this bombarding happened, some observations were recorded. How many alpha particles you are releasing, that can be controlled by you, and you can keep a count of that. He found majority of alpha particles passed undeflected. Undeflected मतलब समझ रहे हो? Majority of the alpha particles which were given from here, these alpha particles just passed undeflected. मतलब ऐसे alpha particles निकल गए. And obviously you can get a percentage of how much you have bombed and how much you are getting as a impression on the other side. Majority passed through. Understood? Okay, fine. Then the next finding he found, very few got deflected. Very few got deflected. Means what happened? Some of the alpha particle actually got deflected. So some alpha particles, very few got deflected. Very few got deflected. These are very important findings. याद रखना है. Number one was majority passed through. Second finding is very few got deflected. And the third one is deflected from the straight path. Deflected means deflected from the straight path. We are bombing it through a thin. Alpha particles are radioactive particles. They have got energy through it. और भूत की तरह आर पार होके आ सकता है. And this is a very thin foil of gold. तो gold को चीर के निकल गया. सबको सीधा ही जाना चाहिए. But some got deflected. Okay. और देखेंगे अभी ना, पूरा चीज को अंडरस्टैंड करना है. तीसरा है and very few, which is 1 out of 12,000 came back rebound. Rebound means 180 degree उल्टा आ गया. ठीक है? Very few. 1 out of 1,000. Children, have you understood this? These are the ones which are deflected. Very few. These are the majority. Majority that went straight. Straight means undeflected. Straight means undeflected. And 1 out of 12,000 rebound here. Very interesting story. But this was the finding. Now we have to, अब हमें जे थॉमसन की धज्जियां उड़ानी है इस फाइंडिंग से, है ना? So we will now marry this with J. Thomson model. Are you ready? ये डायग्राम याद हो गया आपको? ठीक है? इस डायग्राम को साइड में नहीं रखते हैं. Okay, I need the screen. Okay, so I'm taking it off now. Okay. Now let's understand this once again. Our friend J. Thomson had said, क्या बोला था? That the atom is a plum and pudding model बोला था ना? So all the atoms are what? Positive spheres. They should be uniform. Okay. So just a second. These are my gold. Now I'm replacing the gold. Now we're trying to look at it at the atomic level model. These are my gold atoms. And in which year we are right now? We are in the year 1911. What is the story with us? That the atom structure is, atom is electrically neutral. It has a spherical structure, and the whole spherical structure is an evenly spread positive sphere with electrons embedded on it, like plum in a पुडिंग. बहुत अच्छी बात है. तो हमारे रदरफोर्ड साहब ने बोला look Mr. J.J. Thomson, all I released from here were what? Alpha particles. I had released alpha particles. Do you agree or not? What is the structure of alpha particles? They are all positive, 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 positive. These are all my alpha particles. If Mr. Thomson, you said that the atom is entirely a positive sphere, how did my positive particles go undeflected through them? They should have all deviated like charges repel. But the finding that I found, देखो बड़ा interesting है, ये कहानी की तरह ये chapter पढ़ो, कहानी की तरह पढ़ो, that on my zinc sulfide screen, I found that majority pass through. Do you understand? Majority pass through, and they pass through these atoms. Don't you agree? That means the first thing I said, the first thing was what? Majority of alpha particles pass through. दीपांशु सुनने के लिए बड़ा बेताब था ना, क्यों? This concludes, इससे हमें ये पता चलता है, क्या पता चलता है? That the major portion of an atom नेगेटिव होने से यही चिपक जाता. Empty. एटम खोखला है, इसीलिए पार होके चला जा रहा है. Do you understand? Very good. Second finding. The second finding said that a few of these particles deviated. A few of these particles deviated, which means that there is presence of positive charge in the nucleus, not nucleus, in the atom. Mr. Rutherford, you are correct. You said that there are positive charges which are there in the atom, and our findings also find that. So what was our next finding? Our next finding was very few, okay? Our next finding was very few alpha particles got deflected, right? And this means that atom has presence of positive charge. ये तो भाई बात सही है, but not in the manner that you told. You told that the entire atom is what? The entire atom is a positive sphere. If the entire atom was a positive sphere, all the alpha particles would not have passed through. And you said that the electrons are just spread as what? Plums in a pudding. ऐसा भी नहीं है. Positive charge तो है, पर empty है. Third finding was very interesting. Third finding, deliberately I am drawing with a red color, okay, so that it helps you to distinguish. It said 1 in 12,000 came back. 1 in 12,000 came back. So let's see our third finding. Our third finding was 1 among 12,000 had a complete 180 rebound. Now please understand, have you played carom?
Yes.
Do you take a rebound strike? The rebound strike is taken on the bar of the opposite side. The bar, is the striker very hard? Yes, the striker is very hard. But the bar is even harder than the striker. That's why the bar doesn't get damaged. But when the striker hits it, it comes back. Which means my alpha particles are supposed to be very heavy. Mass number kitna hai unka? 4. 4 means they are quite heavy. Such a heavy particle went टक्कर खा के वापस आ गया. मतलब जिसके साथ टक्कर खाया होगा वो उससे भी ज्यादा heavy है. That means it tells that the atom has a dense mass at its center. Okay, and this mass is very, very small. बहुत small है. This dense mass is very, very small. So small that Rutherford postulated that if you have 2 football fields, the dense mass is like the size of a pea. मटर की तरह है एक football field में. लेकिन है बहुत ही tight. Do you understand? In this whole atom, there is some place which is a dense mass. And if there is one unlucky ray which has gone and stuck on that dense mass, it is undergoing a rebound. He further said, yeah, this was his finding. This was the finding. After this, we will come to the Rutherford's model of the atom. So do you find what is Rutherford's finding? The first finding is majority of the alpha particles pass through. So Rutherford came with this finding. This is the experimental finding. Theory is what? That the atom's major portion of the atom is empty or vacant. Second finding of the experiment was what? Few of them got deviated. There is presence of positive charge in the atom. And third is 1 out of 12,000 actually came on a 180 rebound, which shows that the atom contains a central part, which is a very dense part, and all the mass of the atom is said to be concentrated there itself. अगर atom का कोई mass है, तो वो वहीं पे है. And it is so condensed and very small. Why very small? Because otherwise many of the rays should have gone and struck it. Only few gone and struck. वो अभागा rays जो इसके साथ लगा, there are very few, and they had a 180 rebound. With this, Rutherford started giving his model, and he first said that this central core where the entire mass is there, Rutherford started coining this term as the nucleus of the atom. यहाँ से nucleus word का जन्म हुआ. Rutherford said, look, Mr. Thomson, first of all, your theories are not correct. Rutherford came up with his theory and he said, the first statement, the major portion of an atom is empty. The atom does contain positive charge, and he attributed those, because mass of a proton was known at that time. Mass of the proton is much, much higher than mass of an electron. If you just want to have a study, electron's mass is equal to 1 by 1840 times the mass of a proton. तो सोचो इलेक्ट्रॉन कितना हल्का है. समझ में आया? So proton is very heavy, and he said that the nucleus comprises of protons, densely packed, very small in structure, so small that if the atom is supposed to be a football field, then the nucleus is of the size of a pea, मटर के दाने के जैसा, 1 pea seed के जैसा है. And this nucleus contains what? The positively charged particles called protons. So those rays which did not hit the nucleus but were in and around the vicinity of the nucleus, they deviated. And those rays which had a head-on collision with the nucleus, since the nucleus is damn hard, it's as hard as the rebound bar of the carom board, they came 180-degree strike back. So based on this, मिटाओ इसको अभी, ठीक है, क्योंकि ये तो रिकॉर्ड हो रहा है. इसके बाद रदरफोर्ड ने अपना मॉडल देना शुरू किया, and Rutherford's model is very interesting. Rutherford ने कहा, look, now we have the Rutherford's model. He says the atom comprises of a central core, right? The atom comprises of a central core, and this central core he named them as nucleus, right? Nucleus, and this nucleus is responsible for the mass of the atom, and it contains positive particles, which was known till date as protons. So all the protons are present in the nucleus. Then people started asking him, sir, what about the electrons? So he said that the electrons are more stylish, and these electrons revolve around the nucleus in an orbit. ठीक है? तो जितने electrons हैं वो कैसे हैं? The electrons keep revolving around the nucleus, as if planets revolve around the sun. Therefore, Rutherford's model was known as the planetary model of the atom. और इसके लिए Rutherford is the only New Zealander for a long time to have a Nobel Prize. He got a Nobel Prize for discovery of nucleus. Story, just understand. By 1900, we had the plum and the pudding model. Everything was J.J. Thomson's kingdom. And he said that only electrons and protons are the particles that are there in an atom, and the count is same, so the atom is electrically neutral. Rutherford conducted an experiment, famous experiment, which is known as the Rutherford's gold leaf experiment. So gold leaf experiment के findings के बाद Rutherford came up with findings. What are the findings? Major portion of the atom is empty. The atom comprises of a central core, which is known as the nucleus, which attributes to all the mass, which entire mass is attributed to the nucleus. The nucleus contains the positively charged particles, which are called protons, and electrons keep orbiting this nucleus just as planet orbit the sun. That's why this model was known as the planetary model of the atom. अब ये मॉडल का भी धज्जियां उड़ जाएगा, ठीक है? इस मॉडल की धज्जियां उड़ेगी. अब देखो ये मॉडल की धज्जियां कैसे उड़ता है, बता दें? देर हो जाएगा, थोड़ा सा सुन लो, ठीक है? The electron is a charged particle which contains negative charges. Okay. इनसे भी पहले there is another scientist who is known as one of the biggest scientists. His name is James Clerk Maxwell. Okay. Maxwell, long before all these things, had given up one more theory. इसके साथ कोई link नहीं है. Maxwell's theory says, James Clerk Maxwell, your book will not use this name. He says that if you have a charged particle, if there is any charged particle, and if this charged particle is accelerated, समझ में आ रहा है? A charged particle is accelerated, then this charged particle will emit energy. Any charged particle, when accelerated, emits energy. That is the concept of your microwave oven. Microwave oven में magnetron रहता है. The magnetron will make all electrons accelerate. Same is your cell phone. Cell phone में भी electrons accelerate होते हैं तो ही wave generate होता है. इसीलिए खराब है ज़्यादा देर बात करना, because you're talking on the electromagnetic wave. How is that wave created? The wave is created by the acceleration of electrons in your handle for wine. So who is losing energy? Battery से energy जा रहा है. Microwave में भी वैसा ही है. The microwave consumes energy. Now put this theory out here. This fellow said it's a circular orbit. Now we go back to what? We go back to physics chapter number 1, which is kinematics. Sab le aao. If you are having a particle, which is actually moving in a circular path, did you know that? Uniform circular motion is always accelerated motion, because the direction of velocity is changing every time. Speed may be constant, direction is changing every time. So aren't the electrons accelerated? Yes. Are the electrons charged particle? Yes. Then it means this particular electron, after all these electrons, should be losing energy. If they lose energy, rather than following a circular path, they should slowly follow spiral path. दौड़ते हुए एक घोड़े की अगर आप गले को काट देंगे तो घूमते घूमते आगे धाम से गिर नहीं जाएगा. It is losing blood. So it should actually go. And once you lose energy, you're on a spiral path. The nucleus, you only said it is positive, and this is a negative entity. So the nucleus should jump se pull it, and the atom should collapse. That is the drawback of Rutherford's model of atom. Rutherford could not explain the stability of his model. He is attributed to the nucleus, but electron को अभी भी fit नहीं कर पा रहा है. क्या बोला था? Electrons rotate in circular orbit. But James Clerk Maxwell's finding was long back, and it says that any charged entity, when it is accelerated, will radiate energy. Electron is a charged entity, and a circular motion is always an accelerated motion. So electron is accelerated. If the electron is accelerated, it should also lose energy. All the electrons should lose energy, and rather than staying on their orbit, they slowly कमजोर होता जाएगा ना. So they will be pulled by the nucleus, and the atom as such should collapse. So Rutherford's model also went for a toss. Now to save him will come a person whose name is Niels Bohr. Niels Bohr का बेटा आगे बोर, दोनों नोबेल लॉरेट है. Bohr is also Nobel laureate, Bohr का बेटा. ये कहानी आगे क्लास में. How did Niels Bohr now save this model? But that model also could not work for long time. Niels Bohr, इसलिए आप grade 9 में सिर्फ you learn up till atomic number 20. Niels Bohr explained everything from the perspective of a hydrogen atom. आगे नहीं कर पाते हैं. तो बोर की भी धज्जियां उड़ जाती हैं, और श्रोडिंगर का वेव इक्वेशन ही सब कुछ सेटिस्फाई करता है बाद में. ठीक है, आगे चल के आप देखेंगे कोई ऑर्बिट नाम की कोई चीज ही नहीं है. इलेक्ट्रॉन इज ओनली अ क्लाउड, इट्स नॉट इवन अ पार्टिकल. गर्मियों में व्हाइट शर्ट पहन के जाते हैं ना, घर आने से यहाँ पे डर्ट आ जाता है ना शर्ट में. डिड यू सी द डर्ट? नो, बट इट लेफ्ट एन इम्प्रेशन. Electron is also like that. It will just leave an impression. And slowly, when you go to grade 11, these orbits will change. And you will use a word called orbital or orbital. What is an orbital? An orbital is a 3D space where the probability of finding the electron is maximum. My sir used to say, Kabristan samjho. Where is the probability of finding a bhoot maximum? कब्रिस्तान. उसी तरह ऑर्बिटल भी एक कब्रिस्तान है जहां इलेक्ट्रॉन के मिलने की संभावना सबसे ज्यादा है, प्रोबेबिलिटी. बट देन क्वेश्चन कम्स, बट देन हाउ बिग इज द ऑर्बिटल? इतना इतना कितने जगह में ढूंढूं? दैट इक्वेशन इज गिवन बाय श्रोडिंगर्स वेव इक्वेशन, which will give you different shape, dumbbell shaped orbitals, double dumbbell shaped orbitals, spherical orbitals. ये सब आप 11 में पढ़ेंगे. तो ये कहानी वहां तक जाती रहती है. ठीक है, चलिए